Hi, Mr. Unkert here, and in this video, what I'm going to do is I'm going to create a Python game for my students where they have to answer a couple different types of questions. I want this game to be a little different in that I want it to be randomly generated problems following a basic format. So we're going to have two composite problems and then two problems where you have a certain amount of people walk into a room with tables of 4 or 5 or 3 or 4 that sit 3 or 4 apiece, and they want to know how many tables sit a certain amount of people. These are SAT style type questions, so they do follow a basic format. So we'll have 4 questions, 2 of the format of the composite functions, 2 of the tables format, and they'll be randomly generated. Also, what they're going to do is they're going to be trying to cross a river in South America somewhere, and there's going to be various things that nibble on them. All right, we're going to create a list called creatures. These are the potential creatures that are going to nibble on them. So we'll start with an anaconda because we're doing Python, and there's a actual thing called anaconda that you use in Python. Next, we'll have a tigerfish. Those are pretty bad. And then we're going to have a piranha. Might have spelled that wrong. Piranha. Still spelling it wrong. And so part of this video, I will be going and checking out how to spell things, because I'm horrible at it. Piranha. Okay, I spelled it right. All right, so we'll have a piranha as just piranha. No, forgot already. Piranha. Okay. All right, so those are 3 creatures that could get them as they're crossing the river. We'll have a life force variable that we're going to keep track of. At the start of the game, it's going to start at 100. And then what else shall we have? Well, we have to have a coefficient list. And these are going to be, we're going to have to import the random module. So I'm going to import random, and then we're going to have random rand integer, and we'll pick it from 1 to 9. That'll be, and we'll have various coefficients. So I'll do maybe like 5 of these, and actually I can just copy and paste these. Okay, so we have 5 coefficients. We also need some constants, and the same thing. I'm going to randomly generate those. So let me just and copy that. I might be copying the coefficient. Probably am. Just delete that out. Okay, so we now have 5 constants. So that's going to help us. And the last couple constants, we're probably going to change the range. So let's make it from like 20 to 30 for both of these. Okay. All right. So what I need to do is I need to first introduce the game. So we're going to start. Welcome to Math River Monsters. Okay, we're going to print you are in South America and you decide to swim across a river in the jungle. We'll say a guy named Jeremy warns you against it. but you don't listen and start swimming anyways. Okay. All right. And then let's see. Okay. So to successfully make it, spelled that wrong, make it across the river, please answer these questions correctly. Okay, so, all right, we'll start formulating a question. So we'll print an F string. And in the F string, we're going to have if f of x equals, we're going to need a coefficient. So we're going to take a coefficient, first one, so index 0, and that's of x minus 2, and g of x equals, g of x will equal, let's see, let's have a constant this time. So it's going to be a constant. We'll take the first one, so index 0. And then we'll have a minus f of x. What is, and then we're going to do g of, and then constant, and we'll take the second one. What is g of, we'll close that parentheses. Okay, let's try and make sure everything is working. So we're going to run, pick the file, it's going to be River Monsters, run that. Okay, so it's picking, you know, a random, and it has this math equation. Okay, it's randomly generated. Let's run it again. Let's just, okay, so you notice the equation totally changed from last time. The numbers totally changed. So that's working well. So it's randomly generating a problem. Okay, and we want this not to just print. We want it to be an input, and we're going to say it's an answer 1 that equals an integer with an input of all this. Let's go through at the end. We should have 2 parentheses at the end. Yeah, okay. And let's just test that. Okay, let's run it. Okay, we do have an error in line 14. Valid syntax. It looks like we have something going on here. Okay. All right, let's save it and then run it again. Okay, so we've got f of x equals 4x minus 2. G of x equals 6 minus f of x. So let's see, 4 times 2 is 8. 8 minus 2 is 6. And we have 6 minus 6, so this should be 0 actually. And it prints our solution. So good. Okay. So now we have to, we'll take this out and we'll calculate solution 1. So solution 1, well, we had f of x is, so it's going to be coefficient 0 times, it's going to be the first constant with an index of 1. Okay, and then minus the constant Oh, wait a minute. What did we use here? Oh, we should have picked another random number. Actually, let's do that. Let's do constant 2. Okay, so we're going to subtract. Yeah, okay. So we're going to subtract constant 2. And then that's going to give me f of x, but we want g of that. So g of that is the first constant, 0, minus this f of x. All right. We got to wrap this in parentheses here. Okay, and let's print answer 1 to check and print solution 1. And let's run it and test. Okay, so let's see, 5. So 6 times 5 is 30, minus 1 is 29. 8 minus 29 is going to be negative 21. And they match. Okay, so that's good. All right, so these two match, so we're doing well so far. So if answer 1 equals solution 1, well then we're going to print you got the answer correct. You keep swimming. Okay, now if that doesn't happen, okay, we're going to print you got the answer wrong. And then we're going to have a random interval. So we'll call that creatures random. And that's going to equal a random. It's equal random.rand integer, and we want to do it between 0 and 2. Okay, and okay, so what we're going to say is then we're going to print an f string. You were just bitten by a, and then we'll do creatures with an index of creatures random. Okay, so you're getting bitten by a random thing. And then we're going to make a little different things happen here. So, and I may want to create a function above, but what I'm going to do is, you know, if you get bitten by an anaconda, I want that to take 40% of your life force away. If you get bitten by a tigerfish, let's say 30%, and then the piranha, let's just say 10% because they're small. Although you could get bitten by a lot of them. So we'll start with an if statement. So if, and we'll say creatures random equals 0. And this is only happening if you get it wrong. So life force is going to be minus equals, we want to take 40%. All right, we started at 100. And then we'll do an LF. LF creatures random equals 1. The life force, that's going to subtract by 30. And then else, we'll say the life force is subtracting by 10. Okay, and then we'll print, actually step out of the if else, and we'll print an f string. So your life force is currently And then we'll pass in the life force variable. Okay. And then the percent. It's currently at. Okay. Okay. Control S to save. Let's see if we get any errors. Okay. Let's just run it. Okay. All right. So if f of x equals 8x minus 8, g of x equals 8 minus f of x, what is g of 3? So that's 24 minus 8 is 16. 8 minus 16 is negative 8. So let's get it right the first time. You got the answer correct. You keep swimming. Your life force is currently at 100%. Okay, now we'll get it wrong. Okay, so we're going to run. And, all right. So if f of x equals 8x minus 7 and g of x equals 1 minus f of x, what is g of 4? So it's going to be 32 minus 7 is 25. 1 minus 25 is negative 24. So let's get it wrong. Let's just put like 20. You got the answer wrong. Okay, and then we've gotten an error. Okay. You were just bitten by so line 20. Creatured. I spelled it wrong. Okay. Well, it's good we messed that up. Okay, so okay, there's one thing I want to do is I want to take this stuff and I want to create a function. So I'm going to hit Control X and I'm going to create a function up here. And we're going to define it as wrong answer. And then we'll have this stuff happen in the function because we're going to do that more than one time. And I've got to put the parentheses there. Okay. And then we want to call it. Okay. Control S to save and let's run. Well, let me think about that if I want to call it or not. But anyway, so we got f of x is 4x minus 8. G of x is 8 minus f of x. What is g of 8? So we got 32 minus 8 is 24. 8 minus 24, we got negative 16. Let's do something wrong. Let's do 14. Okay. Okay. All right. So I think life force was. So I want to say life force global. I believe that will fix it. Maybe. Okay, well, let's run it and see what we get. I'm just going to pick some random number to throw in there and get wrong. Maybe it's global life force. Let me actually take a look. Hold on one sec. Dun, dun. What do I have to do? No. Global. I have to do global first. Okay. Just global life force. Okay, and then let's run. Okay, let's make some crazy number, 100. Okay, so it's working. Now, the question is, with the next question, I think it's going to call the function, and then the function's going to see, the creature's random, it needs to be in the function. Okay, so because I want to make it new every time. Okay, so let's try that. Come on. All right, let's go with a wrong answer. The answer wrong, you're bit by Anaconda, your life force is currently at 60%. It seems to be working so far. Let's see if we get any bugs as we go. All right. Now let's see. We're going to do another one, another composite function one. So answer 2 equals integer for an input. Do an f string. If, let's do if g of x this time equals, we've got constant 3 and 4. I don't think we used, so constant 3 times x minus, we're probably going to have to come up with another constant 4. And h of x equals, we're going to have to generate another constant up here. That's the coefficients. Actually, we should have used, yeah, maybe not. We should have used, we used, let's see, coefficient 0. So we need to use coefficient 1. Okay, minus, let's do constant 3 here. And then h of x equals, we're going to do constant 4. We will have to create another constant now. Minus g of x. Oops. And what is, we're going to have g of, then in here, we're going to have a constant 5. So we need to go up to our constants. And go to the end here. Oh, and I want these, I still want these constants to be between, we're going to need more constants, between 1 and 9. So I don't want to be getting too high in my numbers for those types of problems. So let's make a few more. So random dot rand int 1 9. Do another one, random dot rand int 1 to 9. Okay. All right. So we've got some more constants. Okay. All right. Now, so that's answer 1. Okay, so solution, or answer 2. So solution 2 is going to equal, well, we've got coefficient 1 times constant 5 minus constant 3. That's going to give me g of x. Okay, I'm going to wrap this in parentheses here. And then for h of x, oh, and we want to know, I think we labeled this wrong. So we want to figure out what h of whatever this is. So yeah. Okay, so for h of x, we're going to have constant 4 minus this. Okay. And then, so now we go to an if else statement. So if answer 2 equals solution 2, then we just want to print this. Otherwise, we would call the wrong answer function. Okay. Let's run it. Okay. So let's get them both wrong. So g of 6. So let's just say 100. Got the answer wrong. I got bitten by a tigerfish. Let's do 100 again. Got the answer wrong. You were bitten by a piranha. We didn't print my life force. So we want to know what my life force is going down to. And the second input, we should just give them a little, we should have a question mark here and then a space. Okay. And then we want to print what my life force is currently at. Do an F string. Your life force is currently at do life force percent. Okay, and then I also want something like if life force. So if you get bitten by the anaconda twice, you're going to be, or anything that brings you below 50, then I want to print your life force is critically low. You are starting to bleed out. Okay. So got that. And let's save it and run it as a test. And bring this back up. We're going to get it wrong twice. So 100. Life force went down to 90. I was only bitten by a piranha. Okay. And I got bitten by a piranha again. I went down to 80. Let's try this. This may be a bug. Okay, let me rerun. Okay, I'm going to do 100. Got bitten by an anaconda down to 60%. Okay, no, it's working fine. So I got bitten by an anaconda, bitten by a piranha. My life force is currently 50%. Let's run it one more time just as a test. Okay, so let's do 100. Down to 60%, 100. Down to 20%. Okay, now it says your life force is critically low. You are starting to bleed out. Okay. All right. Okay, so that's for the second question. So we're making progress on this game. It's pretty nice, pretty sweet game. So I'm going to pause the video for just a moment and then come back. I need to check on my dinner that's cooking, and then we're back. Continue with this game. So let's talk about what is going on here. Let me just move my mic for a minute. Okay. So. Well, we've gotten through the first two questions. Now we're going to the questions where a certain amount of people enter a room, and we want to know, based on the amount of people that enter the room, some of the tables will sit, let's just say 3 people, and the other tables will sit 4 people. And we're going to, now at this point, basically, we're going to have to figure out how many tables sit a certain amount of people. Okay, so let's just make a comment, and we'll put, these are the tables problems that we need to create. Okay, so what I'm going to do is create a variable called table groups, no, a list rather, and we're going to randomly generate that. And these are going to be from 20 to 30. let's do 4 of them. Okay, very good. All right, so now we need to figure out the total number of people. Okay, so what we're going to do is have a variable called total people 1. This is for problem 1. Now you could probably do this a little bit better, but this is the way I'm thinking of it right now. But so we're going to have the table groups. So we're going to have table groups index of 0, so the first one in the list, times 3, plus table groups index 1, and we'll make that times 4. So that's going to give me, you have basically the amount that is basically the amount of people that's sitting at the tables that sit 3 people, and the amount of people that are sitting at 4 people. So we're going to have some number between 20 and 30, and then for the number sitting at 3, and some number between 20 and 30 for the number sitting at 4. Okay, so now we're going to have to print an F string, and we'll say total people 1. Enter a room. Some of the tables sit 4 people or sit 3 people, and we'll just print another line here. While some of the tables sit, or while the rest of the tables sit 4 people. Print another line. If all the tables are filled to capacity and everyone gets a seat, and now we'll do our input, so this is going to be answer 3, and we want to wrap it as an integer. And we're going to ask, if all the tables are filled to capacity, everyone gets a seat, how many tables sit 3 people? Okay. Now the solution, well, we're going to just take this part here. So this is rather fairly easy, okay? And the one thing I'm forgetting here is the total number of tables. So we have to add that in. So total tables 1. So we have the number of people, but the total number of tables is going to be table groups, that first one, 0, plus table groups, and the second one in the list. Okay, so that's going to give us the total number of tables. We'll just print another line here, an F string. There are, and then we'll put in total tables 1, tables in the row. And then capitalize this. New sentence. We'll have our grammar be proper. Okay, so now the solution is the total people 1. Or no, sorry, the solution is table group 0, rather. So if answer 3 equals table groups 0, and we've got to have double equals here, then we're going to print you got the answer correct. Okay. Otherwise, we're going to call the wrong answer function. Okay. All right, so we've got that. Okay, so now with being bitten by an anaconda 3 times, they could have a life force that is a negative number. So we're going to have to have an if-else statement. So if life force is, we'll just say, greater than 0, then we're going to do some, we're going to continue the game. So I'll just put in a comment here, continue the game. Otherwise, we're going to say you died. And when we continue the game, we'll print something like their F string. Your life force is currently, and then we'll just do is currently at. Pass in the life force variable and the percent. Your life force is currently at that. Otherwise, we're going to print game over. Okay. All right. So we're going to save it and make sure this part works. So now we're going to run it. And we've got some, we messed up. We didn't put a comma in, where is that? Table groups. Okay. All right, and we're getting 2 errors. Well, I'm just going to run it and see. Oh, here's an error. Don't want that. Okay, I think we're okay at this point. All right, let's run it. Okay, so put in the wrong answer. Put in the wrong answer. Life force is critically low. We might want to do something with the bleeding. We'll put in the wrong answer. We know there's going to be not 45 people. That's tables that sit 3 people. So you were bitten by an anaconda. You died. Game over. So that works. All right, now let's run it with the correct answers. Okay, so let's see. G of 2. So 3 times 2 is 6 minus 6 is 0. 4 minus 0 is 4. So let's do that. Got the answer correct. You keep swimming. Your life force is 100%. H of 5. So 25 minus 5, it's 20. 8 minus 20, negative 12. Okay, you keep swimming. 183 people enter the room. Some sit 4, some sit or some sit 3, some sit 4. There are 51 tables. If all the tables are filled to capacity, everyone gets a seat. How many tables sit 3 people? It's a great question. I would have to figure that out. And I don't feel like doing that right now, but let's say no, 83 is not divisible by that, so 104, 83, let's see, that's 79, it's not divisible by 3, 96, 87, 87 is divisible by 3, so it'd be 24, sit 4, and then what did we say? We said 87, so it's going to be 2, and 27, 29. I think this is right. No, I got it wrong. But I was bitten by an anaconda. Okay. What would the correct answer be? So 29 times 3, it would be 87. And then you would have, oh, but there's 51 tables. That would only leave 22. Yeah, I forgot that part. Okay, so yeah, I didn't do that one quite right in my head, but I believe it's working well. After I come up with the next problem, we'll test it and run through and make sure. Okay. All right, so we have our table groups. Now we've got to have this again. We're going to copy this code, but change it slightly. So I'm going to copy this. Paste it. And we'll change these to 2. 2, and then this is going to be 2, 2, and this is going to be 3 and 3. Okay, and we're going to change it to 5 and 6, and then we'll do 5 and 6. Okay, and then total tables 1. We're going to have to change it to, we have to do a total people. No, we have total people too. Okay, so we'll change it total people 2, total tables 2. Okay, and we're just going to copy this and change a few things. And well, that answer 4. How many tables sit? 6 people. Let's do it that time. And that's going to be table groups 3. So we'll say if answer 4 equals table groups 3, and we have to do double equal signs. Then we're going to print you got the answer correct. Okay. Else we're going to call in the wrong answer function. And then we're going to say if the life force is greater than 0, we're going to say that you swam across the lake successfully. No. Well, hold on, I'm going to change something here. Print you swam across the lake successfully. Now we'll print another thing, an F string, just your life force is at, we'll do life force and percent. Your life force is at life force is at whatever percent it's at, and this is going to be when it's greater than 50, okay? And then we'll do another one. If life, actually let's say greater than 60, because you got to get at least a 60 to pass. So if life force is greater than 0, so this time it'll do something that's between like 0 and 60, print, well, you're going to make it across the lake. You made it across the lake. Okay. Print, but your life force is only, no, no, but your life force is only whatever percent it's at print you bleed out. And we'll have game over. You lose. And we should make it clear that they lose here too. Okay, in this one, the first scenario, we'll just say congratulations. You win the game. Okay. All right, so that's greater than 0. But if it's less than 0, so else, we're going to print an F string. No, we'll just say your life force is below 0. Or now we'll just say you died. And then print game over, you lose. So you didn't make it across the lake even. Okay. All right. So let's run this. Okay. So G of 6. So that's going to be 18 minus 2 is 16. 1 minus 16 is negative 15. We're going to get that one right. Okay, you got the answer correct. You keep swimming. Your life force currently at 100%. Let's get this one wrong. So we'll do 42 minus 3. Let's just, that's going to be, 42 minus 3 is going to be 39. So that's going to be negative 30. We'll just say positive 20. You got the answer wrong. You were bitten by a tigerfish. Your life force is currently at 70%. Okay. 193 people enter the room. Some of the tables sit 3 people. The rest of the tables sit 4 people. There are 55 tables in the room. Let's just get this wrong. Let's put a number like 45. Hit enter. Get the answer wrong. You were just bitten by an anaconda. Your life force is currently at 30%. So okay, you're still alive. 275 people enter the room. Blah blah blah. I don't know. I'm gonna get this wrong. Okay. You've just been by an anaconda, so your life force went down to below 0. You died. Okay. Let's run it. One thing I wanted to think about when I was running this is we're down to this statement. If it's greater than 0, okay, we continue the game. Otherwise, you died. Game over. Okay, so that was if you were bitten by 3 anacondas. Okay, so let's try and get 3 right this time. Let's rerun it. Okay, so G of 7, so that's 49 minus 6 is going to be 43. 4 minus 43 is negative 39. Okay, got it correct. H of 4, that's 20 minus 3 is 17. 8 minus 17 is negative 9. Get the answer correct. You keep swimming. Still at 100%. Okay, 194 people enter a room. Some of the tables sit 3 people, while the rest of the tables sit 4 people. There are 56 tables in a room. So, I've got to set up a little equation here. And actually, let me open up a tab and we'll work through this problem. Do a little math while we're here. Was opened up way too many windows here. Okay, so this is how we're going to set up this equation. So there's 194 total people, 56 tables. So the number of tables, x plus y, is going to equal 56. Okay, and then 3x plus 4y is going to equal the total number of people. So we set up our system of equations. Okay, and we have 194. So I'm going to multiply the top by -3. Okay, so that's going to eliminate the x's, right? Boom, boom. If we add them together, we add -3y plus 4y. That's just going to give us y. We're going to have -168. So 194 minus 168. Okay, so take one here. So we get 6, so 26. So our solution should be for y, 26. Meaning that x is going to be, the number of tables that sit 3 people is going to be 30. Let's see. So 30 times 3, that would be 90. 26 times 4 is 104. That works out. Okay, so we're going to put in 30. You got the answer correct. Your life force is currently at 100%. All right, we're going to get this one wrong. We'll just do a number above 30, which we can't be. And then it says, you got the answer wrong. You were bitten by an anaconda, but your life force is only 60%. You bleed out. Game over. You lose. Did I make that happen? Oh, I have to put greater equals. Yeah, let's just keep it greater. You could die just by being bitten by an anaconda right at the end of the game. Anyways, I'm going to continue to test out this game. So this I hope it gives you an idea of what you can do and what kind of game you can make. I would need to, if I'm running this, and we take a look at this. If I'm running this, a lot of text is jumbled together. I don't have any pictures of, so hopefully I could get a picture of an anaconda, and then what I would do is I would import it into this file, and I might look some ASCII art up for that. So that might be a different video for a different day. But I hope this gives you some ideas on how to create a game. So thank you for watching, and have a great day. Hi, Mr. Unkit here. And so in this third part of this video, I'm going to bring in some variables of ASCII art for the game. So I'm going to create a new file, and I'm going to call it variables.py. Okay, and so we need an anaconda, we need a tigerfish, and we need a piranha, and we need a grim reaper, and we probably need a party if you win the game. So let's go and let's just search some things. Close up the drawing tools. Okay, so we're going to say ASCII art. Let's do a snake. Okay, see what we got. This one looks like it could be a good anaconda. All right. So hit Control C to copy that, and we'll say anaconda. Equals, and we'll paste it in. Okay, and then we also want a fish. Well, we want 2 fish. So let's do fish. One's a tiger fish. That one's probably going to need to be a bit bigger. And then maybe not do any of these. And then the other one is going to be, okay, so we'll say this is the tiger fish. This is one's a little bit bigger, and then we'll do that one for the piranha. So okay, we'll copy that one in. And then let's see, we got to do the piranha. That's how I remember how to spell it. So the piranha will be the smaller one here. Yeah, the piranha is the smaller one, and then we'll have death. And we're going to have to find a Grim Reaper. All right. I tend to like this one quite a bit. So we'll copy that one in. Okay, and then we'll also have party if you get to the end. Sorry about the squealing tires out there. I don't know what they're doing. Not party hat, just party. Just want to party. All right, and let's see. Oh yeah, these dancing people. Those will do. Okay, so we've got our variables file, and we want to import our variables file. Okay, and the other thing we need to do is we need to call it. So we have a wrong answer, and we want to do it in this wrong answer function, I believe. So yeah, we're going to have to print each of these. So the first one's the anaconda, so I'm going to print variables.anaconda, and then let's print variables.tigerfish. So next one. Finally, let's print variables.piranha. Okay, then we'll go down here. So okay, if you die, you're going to want to print variables.death. Okay. So if you bleed out, so both of these we're going to print variables.death. Okay. And we'll save it, and now we gotta have the party. Okay, so we'll print variables.party. Save it and run it and see how that goes. Okay, so let's get it wrong. Let's do 100 something. You're just bitten by a tigerfish. Okay, so then the tigerfish comes along. Okay, cool. Let's get this one wrong. You're just bitten by a piranha. Your life force is currently at 60%. Uh-oh. We'll get this one wrong. 45. Just bitten by a piranha. I'm down to 50%. Okay, and I'm going to do this one. So then you're just bitten by an anaconda. Okay, you made it across the lake, but your life force is only 10%. You bleed out, game over, you lose. Okay, awesome. So that concludes making this game. I would continue to probably format this a little bit, but right now I'm going to leave the imagination of what you could do with a math game like this built in Python up to you. How would you improve it? And if you think you know how you would improve it, please leave a comment in the comments below. Also, please remember to like and subscribe to the channel, as it really helps the channel grow. Thank you for watching, and have a great and wonderful day.